Hello guys, welcome to the Python tutorial on how to create a IK joint chain by just select a curve. Okay, I just finished it, and let me just do it again here using Python. Let me show you what it does. So what it does is you just need to create a CV curve like this, right? And you type in how many joins you want, for example 15 joints, maybe 15 joints, and then you grab the curve you create. It's gonna create a joint chain for you with 15 joints. Let me make them the radius smaller. It's gonna create that for you along that curve you create, and they're all very well oriented, and they're all on the curve with no exception. Okay, so that you get a perfect joint chain for IK. And in this code, it also does the IK handle for you already. So the IK is there, and you can actually start doing something with this IK now. But I don't want to go over this last part to do the IK thing. But you can see the the core functionality is actually just create this joint chain. And now this is of course sometimes not for IK, so I'm not gonna do this IK part, but it's just one very simple line of code to apply IK on it, so which is this guy. Anyway, so let's go start from the beginning and talk about how everything is done here. Okay, you can keep my curve there. Oops. Alright, so first we start with import my as commands as MC. Okay, and then the first thing I want to do is design my UI. Now you can design the functionality first or the UI first. Sometimes I found that doing UI first will give you a bigger challenge, because you want to design how the user uses it first, and then you design how to actually make it work, and that's going to be more intuitive, at least to me, for the users. Anyway, so I'm gonna do a window here. I'm gonna go for the easiest way, so I'm gonna do close window or anything. This is the window, and MC dot show window. Okay, let me make it bigger. So I'm gonna show the window, and what this does, if you run it now by pressing Ctrl A to select everything and Ctrl Enter, it's gonna be run, and it's gonna be like this. Now a few things you want to change is the title of the window will be equals to create joint chain along curve selected. Okay, run it again. You see now the title changes, and then I want to also implement some of the buttons and UI elements inside of it. I need first a layout. I'm gonna go for a row column. Layout, and number of columns equals 2 columns. Got an error. Number of columns, not MC, NC equals 2. Okay, so now I have 2 columns. It's not showing up because I don't have anything inside of it. So let me do the first thing, which is the text. I'm call the label it with join amounts. Okay, another int field, and it's going to be default with the value equals to 5. Now you see join amount and 5 over there, and let me go ahead and do 2 more buttons. This button will be labeled with create, and another button which is labeled with cancel. Okay. Now if you run it, you have now all the elements that I have earlier, and I can define the width of the buttons equals 150. If I want to stretch my UI longer, I can do that. So the easiest way that you can go for 150 and 150. Now you can see now they're all being stretched evenly with 2 columns for UI elements. Alright, so this is the UI part. You can actually label the UI part with some fancy labeling techniques like this. Let me make it longer here. And gonna type in UI in the middle, and then have another hash at the very end. Seems like I wanted to maybe have 2 more space. Actually, 1 more space there. Okay, so that's the UI portion of my code. Copy this label and go all the way down and create another label and call it methods or functions, whatever you want to call it. I think in Python they wanted to call it method, but they're basically the same thing. Method. Okay. Now my method is very simple. I just need to create one method for the create button. And by the way, the cancel button can have a simple command. Command equals mc dot delete UI. Okay, the UI we're gonna delete is the window, so we can actually make it here a new window or my window equals that, and that's gonna be what's inside of the delete UI. Alright, so now if I run the code and do cancel, it's gonna close the window. Oh, I don't have that. Delete UI is not correct. Let me take a look at the thing here. I don't know why. Let me try type it in here. Sometimes I just need to see. I'm too used to the advanced API. Sometimes I just don't remember the name. But anyway, delete UI, right? Yeah, that's delete UI. Forget that. And E, I guess. Okay, that's it. So let me put in 2 quotation marks. Run it again and then cancel. We'll cancel it. I have too many windows open, so let me close those guys. Alright, now if you click on cancel, it's gonna just go ahead and close it up. Let me go ahead and do the other command that we'll use for my button. This command will be equals to whatever I created down here. Let me define it. Create join along curve. Alright, and then I'm gonna copy the naming here, and the command will be equals to this guy with 2 parentheses, and here we can test it. We can print creating and run it again, and you press create. It's gonna print out that creating, which I tapped that wrong. Creating. Okay. Anyway, so I don't really need this just to test if everything is hooked up properly, and then I can start doing the functionality that I need, which will be creating joints along the curve. First of all, I want to know how what the curve, which one is the curve, which is currently the thing being created. So let me type in curve. Selected will be equals to mc dot list selected equals true. So this will give me everything I selected. I'm gonna read the first one. And if you have multiple things selected, that doesn't matter. If I just need the first one here. Okay. So now I have the curve, right? No arrow is there. Again, Control A, Control Enter to run the code. And I'm gonna go ahead and do more settings. I need to know how many joint do I want. The joint amount will be here. It's gonna be equals to whatever inside of the text field here. So I need to give the text field a variable to store the name. So joint amount text field, not text field, actually int field. Sorry about that. Int field. Okay, this guy will be equal to that, so I can actually query now. mc.int field. I'm gonna query this guy, so q equals true, and value is the one I'm gonna query, so v equals true too. So now I know the amount of joints I want to create. Can make it smaller. Alright. Now it's still not doing anything yet, because all we are doing here is gather the information. You can of course comment this part as gather info. Okay. Now I know the curve I want to create my joints on. I know how many joints I want to create. I need a for loop to go create those joints. For I in range. The range will be from 0 to joint amount. Okay. And then I'm gonna create joints. So new joints will be mc joints, and I don't really want to give it a name, but you know what I mean. Now if I do create, it's going to create 5 joints for me, and they're all underneath the curve, which is not what I want. I want them to be separated at the beginning. So let me actually cancel the selection here first. Select cancel equals true, so I'm not selecting anything. Now if I run it again and create, it's gonna grab the curve and create. It's gonna create all 5 joints, all separated from each other. Alright, and then I want to attach the joint to the curve, which the command will be, if you're doing that manually, it's gonna be underneath animation, constraint, motion pass, attached to motion pass. You can see that's the command right here, so let me do that. It's gonna be mc.pass animation, and the pass animation, I'm gonna need the joints, so it's going to be the new joint, which is the one being attached, and the curve you attach to will be equals to C equals to curve selected. Okay, and I guess you don't have to choose select all those define all those things, but I think this fraction mode actually is needed, so let's gonna make that equals to true. Right, that's all we need. Now if I run it again, let me delete my original joints and create. Oops, got an error. An invalid argument for curve flag. Oh, I actually don't need the semicolon. Sorry, the quotation mark there. I'll do that again, and then grab the curve and create. Now you see 5 joints being created, and they now have the motion pass, and they have a U value here on the motion pass. And the U value will be ranging from 0 to 1, and if you change that from 0 all the way up to 1, it's going to reach to the end of the curve. Alright. Okay. So after that, I want to actually, let me go back and take a look. You see now this motion pass is actually how I use to position my joints, but I need to break the connection there though, because it does have animation on it. So I'm going to delete the animation. It's going to be mc.cut key, right? To delete the key I'm going to cut out or delete will be the key on the motion pass. So I need to have the name of the motion pass. I can create a variable here. Motion pass will be equals to that, because this guy returns the name of the motion pass being created. So I need to cut the key of the motion pass, and I'm going to specifically cut the ones on the U attribute, and I'm going to cut the time, right? The time that will be cut out will be infinite, so all the keys will be deleted. If I run it again and delete my joints and do it again, now you see my joints now still have the motion pass, but now have no animation inputs. Okay, after this, I'm going to go ahead and set up their U values. So for the U values, I'm going to do set attributes, and the attribute will be start, will be the motion pass, a motion pass U value here. I can copy this guy here and paste it down there, and then the value I'm going to set up though will be a little bit of a mathematical calculations. So what I need to do is I need to separate the range from 0 to 1, right? That's how the range for the U is from 0 to 1. I want to divide that into multiple chunks so that every joint will have a different value. So the mathematical representation of that will be the I, which is the current joint's index, multiplied by the increment that I will have for every new joint. It should move on the U direction here a little bit more, right? And that incrementation will be actually 1.0 divided range from 0 to 1, right? This range divided by how many segments between those joints, or how many sections I want to cut this curve into, so that every segment will have a joint. And you could assume that that is the joint amount, but actually you need the joint amount minus 1, because the first one doesn't really need a segment. It starts with 0, so that's why we're using joint amount and minus 1 here. All right, let me run this again and delete my joints. Grab the curve and create. Now you see all the joints are now being evenly distributed along the motion path, and you can see now they're all having a different value here. This time they're having 0.25 because sorry, they're incremented by every time by 0.25. So this guy is 0.75, this guy is 1, and the second guy is 25. Third guy is 0.5. Okay, so that is gonna be the joint amounts, the U value I'm gonna set up for those joints. Of course, it's gonna work for more joints. If you want to go for 10, you can go create 10 joints. Will be also created and eventually evenly distributed. And if you take a look at their values, I could assume that it's maybe 0.11 because it's not gonna be easy to divide, but it's good enough anyways. So now I have this value here, right? Now one thing you want to avoid is the 0 value, because if the value here is 0 or 1, this value is going to give you error, right? So you may want to set up the things here that the v value cannot be lower than 2. So you can give it a limitation here. If you go double click on it and right click, go to the quick help, and you can set up the values. I forget how to max value and mean value trade. So you can set up the mean value to be 2, right? So min equals 2, so that you will never get error. If you type in 1, it's going to go to 2 because that's the minimum you can create. All right, just a little detail that you can do here. Now we have set up the for loop to create the joints. Afterwards, I'm going to go ahead and delete that motion pass because I don't need those guys anymore. Delete motion pass. Right, the motion pass will be here, but before I do that, I need to break the connections. I'm gonna delete the joints translate x, y, z values, their input connection. So input connection ICN will be equals to true. So I'm deleting not the joint, but the input connection to the translate x, if that makes sense. So let me paste it in here and paste one more. Okay, so I'm deleting y and z too. So all 3 channels x, y, z translate will be breaked from the connection from the motion pass, and then eventually I'm going to delete the motion pass here right away. Now if you run it again, let me do it, close all the windows I created earlier, run this again, and then let me go create. You can see now the joint are being positioned, but now the motion pass is gone because I don't really need those after positioning the joints. Alright, now it's time to put the joint underneath their hierarchy. Okay, now there is a little different here though, because the first joint doesn't parent to anything. So if the I equals to 0, right, then we're doing the first joint. So what we do is we just don't parent, but we need to define the previous joint here equals to nothing. I'm gonna set up this variable here so I can actually change it down the way. So if I equals 0, previous joint will be the current joint. Remember that this is a if, so only when the I equals to 0, that's the time this guy will be run. Right, so that means only when we were creating the first joint, this will happen. So the previous joint becomes the first joint. Okay, and we continue. So we're not going to care what's happening next because that's all we wanted to do for the first joint. For other joints, if this never gets run, if it's the second joint or any joint after the second joint, this will be false. So this will never be run. The for loop will continue, right? Not stop here and go right away. This continue means, okay, we want to actually go directly to the next loop. But if it's not going to run because we're not doing the first one, everything down here will still be considered or still be ran. Anyway, so for any joint after this, I'm gonna do a parent. I'm going to parent the new joint being created to the previous joint, and I'm also going to set up the previous joint to new joint after parenting. So the next joint, the next joint being created, it's going to parent it to the current joint because I changed what the previous joint is in every loop. Okay. Right, now if I run it again, And let me close all the windows, run it again. Right, grab the curve and then create. You can see now my joint chain are being parented properly. Alright. Now one last thing here is that those joints are not oriented properly. Their orientation are all the same as the word because they're being created in a separated way. So I just need to do one more thing to reorient those joints. But I need to know which one is the root joint. So let me type in the root joints equals to nothing here yet for now. And then when I'm doing the first joint, will be this guy here. I'm gonna I'm gonna type in this guy equals to new joint 2, so that I'm tallying. I'm actually changing the root joints when I'm creating the first joint to make the root joint equals to the actual root joint. Okay. Now let me jump out of the for loop. I'm gonna do a joint. I'm gonna do a orange joint. And if you go to the orange joint here right away, it's gonna be underneath the rigging skeleton orange joint right here. Let me reset settings. And if you do that again here, see now those are the settings, right? So we're gonna orient the root joints. We're gonna use the added equals true. We're adding the joints. We're doing orange joints. Orange joints will be using XYZ axis. So equals to XYZ right here. And secondary axis orientation will be equals to yup, right? I can actually go to the quick settings, quick help, so I can see what that is. Secondary axis orient. This guy here, SAO. I'm gonna use the shortcut for it. And that equals to yup, Y up. And joint hierarchy using the children or orient the children also equals to true. Of course, I want to orient everything. ZSO, I don't know what that is. Let's take a look. 0 scale orient seems like something really useful. I'm just gonna copy whatever is there to here, right? All right, so ZSO equals true. Let me run this again. Close my window here and delete that and grab the curve and run it. And then create. Now you can see the joint chain not only is being created properly, and they're also being oriented properly too if you look at their axis now. Okay, so that's the process of the coding. So now I have a perfect code. It's only like 40 line. It's nothing. And we have used a lot of space doing this, so it's not a very complicated program, but it can go a long way for us to create IK handle. And just notice that this is not going to be evenly distributed. Sometimes if you drag some of the vertices really close and some of them are really far away, and you do like maybe 5 and do that again, you see now their distance are actually pretty good here. But you can see those two are closer, right? Because my vertices are getting denser here. Now to avoid that, you can recreate or rebuild the curve here, right? You can rebuild it. That's 10 maybe. That's going to give you a even distribution of the UVs. Now if you do that again, you see now their distance is supposed to be the same, more or less. It's still kind of dense here. Maybe the rebuild doesn't do a very good job on doing that, but we don't really need to create things like that. Oftentimes we're just going to need a very smooth curve, and it's going to do the job very nicely. Anyway, alright. And you can go ahead and do the IK now. It's gonna be the rigging skeleton create IK handle, IK split handle, and check out auto create curve and auto parent curve, and just click on the beginning and click on the end and then click on the curve. Now you can see it's gonna be perfect. The joint will not be moved at all, which you know it will move if you make Maya create the curve for you. And you can actually see that by looking at the rotation values of all those joints. They're all 0 because they're not being moved. Alright, so this code serves for that purpose of creating a curved joint chain for IK spline without actually causing any values in the joint chain. It will cause some rotation values if you just make Maya to auto create the curve for you. In this workflow though, we just create the curve first and then we do the joints. It's also going to be useful when you want to create some sort of a rig for a snake, right? If you can just go ahead and do the curve first, and you can just easily define how many joints you want, and you can do different testing and create a joint for the snake really quickly. Alright, that's gonna be it for this tutorial. I hope this works, and this method can be slightly changed to allow you to duplicate a object along a curve multiple times if you want to try that. Alright, thanks for watching. See you next time.